Friends, today we are going to discuss with you a very important activity of turbine which is involved during major overhauling or during first commissioning of turbine. That is, the activity is called centering. So, why, before going to discuss why centering subject, before going to discuss with you regarding centering, I want to tell you one thing, why centering is required. Why centering is required. Because the main purpose of centering is to keep the rotor center line with casing center line same. But we know very well the casing are subject to very high temperature. It attain the temperature of the steam which is we are introducing inside the turbine. Suppose we are introducing the steam at 505 degrees centigrade. So turbine casing is going to attain the temperature of 505 degrees centigrade. 505 degrees centigrade. If bearing housing are the integral part of the casing, which is normally happen for the small turbine and other compressor and pump, etc., the bearing housing is also going to attain the same temperature. So when we are keeping the bearing, journal bearing and axial bearing inside the bearing housing, the bearing housing, when it attain the temperature of 505 degrees centigrade or little bit less, then what happen? It is supposed to expand radially as well as axially. So whatever bearing we are going to use, journal bearing or turbine inside the bearing housing, it will get loose and that will create a high vibration. High vibration. So this is the reason we are keeping bearing housing outside the turbine casing. Then I want to tell you another one thing. The turbine, particularly for condensing turbine, it is fixed at rear end. It is where it is connected with the condenser. So that side its movement is nil. So turbine will, as the turbine is subject to high temperature, the 505 degrees centigrade, and suppose the turbine length is 2 meter. So its expansion will be around 5 to 10 millimeter. Because we know L2 minus L1 is equal to L1 alpha T. L1 is the initial length, L2 is the final length. Alpha is the coefficient of expansion. Delta T is the temperature difference. So 5 to 10 millimeter expansion will be there. So turbine will expand on the front end side because turbine are resting on the spherical washer. I will show you one by one the pictures. And when the turbine will expand, turbine casing, it will push the turbine casing is tight with the bearing housing with the tie rod. So it will push the bearing housing parallelly in the same direction of the casing, And regarding centering, I have told you the meaning of centering is that to keep the rotor's center line and casing center line same. So as the bearing housing are outside, so whenever we are doing for major overhauling, when you are taking out the rotor, when you are taking out the carrier blades and top bearing housing, turbine casing, and due to any reason for the cleaning of the turbine rotor or carrier blade, etc., and once you put it back, you need to do the centering again. Centering again. So how we are doing the centering again? Because original bearing equipment manufacturer, they are doing the centering at their shops, and they are giving a sets of reading. They are taking the reading with the bearing housing and with respect to the casing, and that particular reading they are giving along with the turbine, which was which are dispatched to sites. And that reading, once we take out the bearing, take out the turbine casing and rotor, etc. We are a guide belt carrier. We have to achieve the same reading. Same reading. Then only we can say the turbine rotor is the same center line with the casing. Like that, the guide blade carrier, here guide blade carrier, when the centering is over or with bearing housing with respect to the turbine casing, then individually one by one guide blade carrier you have to do the centering. Guide blade carrier, it is going to rest on the buttress of lug. I will show you the next picture, and wave and waves 8 are provided to locate the guide blade carrier axially. If you see the next drawing, you see it is resting on the resting on the buttress of lug. This one is called the lug. Here, both sides are there, and there is a guides are there, and guide blade carrier is also having the grooves. So these grooves, with these grooves, it will guide to it will be pushed inside. So with these ribs, and it will be resting on here the buttress on the lug with the help of your spherical washer and threaded cup and this one is called the exhaust hood, and this one is called the parting plane of the, it is the bottom half of the turbine, and top half of the turbine will come, and then this bolt will be tightened. This is the ESV, emergency stop valve. Emergency stop valve. Then how we are doing the centering, because turbine, front bearing and rear bearing need to have movement to do the centering. So we are using some spherical washer. You see, you are using some spherical washer. This is the this front bearing housing. You see, this is the front bearing housing. This one is the front bearing housing. It is resting on the spherical washer and threaded cup. This is the tie rod where the casing is mounted with the casing are tight with this tie rod to the bearing housing. When casing will move, this tie rod will push the bearing housing in the direction of the casing. And turbine casing also, I have told you, this is the top half of the turbine casing, the bottom half of the turbine casing. The top half of the turbine casing is resting on the spherical washer. You see, this is the spherical washer. This is a fixed part. The threaded cup resting on the and you see this is the expansion, gaps are there. So when the turbine will expand, this will expand on the spherical washer, and from here it is tie rods are mounted. It will move the bearing housing also, and this is the bearing housing, and here it is also a fixed part. It is also horizontal movement. It is guided against these ribs. This is the spherical washer. This is the threaded cup. So if you want to move the bearing housing both direction, it's possible. What we have to do? We have to lose this one. We have to lose one guide spherical washer loose. Then we have to tight this one. Once you tight this one, as this one is loose, so your bearing housing will move to this side. Move to this side. And similarly, suppose you want to move the bearing housing that side. So what we are going to do? We are make this one loose and tight this threaded cup, so that, and it is a fixed point, so this will move this bearing housing in this direction. Similarly, up and down movement with possible with the threaded cup. If you rotate this threaded cup, with the spherical washer, bearing housing will move up and down. So what is the centering reading? You see, the every QC book, quality control book, the turbine manufacturer, equipment manufacturer, they are giving this type of reading. These readings are taken on the bearing housing with respect to the turbine casing. You see, TB is the thrust bearing reading, FOS the front oil seal, and then FSG from steam gland, that is the turbine casing, and front oil centering. Point oil centering, it is inside the rear end of the bearing housing. Similarly, the rear side is also having the similar type of reading. If you see the previous diagram, you see the previous diagram. You see here we are taking the oil seal readings. Then here we are taking the centering reading, front rear end centering. Here the oil seal reading, rear oil seal reading, and here the outside gland of the casing. So we will get this reading you will get this reading. And then once you remove the turbine casing, eh, and rotor guide blade carrier, we have to achieve this reading with the rotor and the casing. Once you get the same reading, you can presume that the your centering over. And this is the dial gauge which we are using for doing this center alignment centering reading. Center reading. If you are using the plunger type gear, plunger type dial gauge, then you see the clearance is very less because the rotor shaft will come, and then there will be maximum 2-3 millimeter, the just 10 to 15 millimeters gap will be there, or slightly more. So there dial gauge, the plunger type dial gauge mounting is not possible. So this type of dial gauge, called lever type of dial gauge, that we have to use so that it can be, width is very less, and this lever it will touch, and depending upon the movement of this lever, the dial gauge reading will get. So once the internal centering is over, front bearing housing with turbine casing, then we have to put the guide blade carrier. Which guide blade carrier will install first? Which guide blade carrier? Because the rear side guide blade carrier we have to install first. Why? Now rear side is having the more area. This area is more, this area is more, this area is less, because it is high pressure, and here it is gradually coming down to low pressure. Area will be more, and here clearances will be more. So we have to put the rear side guide blade carrier first, then resting on this to the buttress with this groove, then put the rotor, again the top half of the guide blade carrier, tight it, then move this rotor up and down. You will get the clearances. Because turbine rotor will touch the rear top half of the fins and the bottom half of the fins of the guide blade carrier. So you will get the clearances, and you have to keep the rotor in the center position, with the help of this guide, with this spherical washer. Up and down movement, horizontal movement, and angular movement. There is also axially fixed, but slight bit clearances is there. Their angular adjustment also can be done. There is some eccentric boosts are there. You move the eccentric boost, so that guide blade carrier angular movement will be achieved. That once this one rear side guide blade carrier centering is over, then you remove the top half cover of the top half portion of the guide blade carrier. Put the next guide blade carrier bottom half, put the rotor, again put the top half cover, tight it, and again do the same exercise and keep the guide blade carrier perfectly at center, so that the clearances of guide blade carrier fin with respect to rotor, and rotor fin with respect to guide blade carrier will be the same universe all over, right, top to bottom and radially. So once by one the radial guide blade carrier, once you and centering is over, then you have to uh, lock the you have to lock this threaded bush. This threaded bush with this lock. Now you see that there is a bolt is there, so you tight the bolt, it will tight the threaded cup, and then you tack it. Tag this, so that there should not be any movement due to vibration or anything. The threaded cup will be fixed, and then here the spherical washer will be there, upon which the bearing housing, or say your rotor casing will rest. And once you see, this is the top half of the bearing casing, this is the bottom half of the bearing casing. So once these are intermittent horizontally, they are bolted. So once you remove this all the bolts, when you take out this top half of the bearing casing, you see the bottom half may fall down, because there is no bolt now in the parting plane. In the parting plane. So what we have to do, this is the fixed part. So what we have to do, there is jacking bolt position is there. You have to tight it before opening this parting plane bolts. You have to tight it so that the bottom half will rest on the jacking bolt. Then you remove this parting plane bolt and remove the top half. And once the everything is over, Then when the top casing is mounted, tightening is over and is resting on the spherical washer, then you remove this one, and then the bolt, both top half and bottom half are tightened, so it will rest, bottom half will rest on the top half and top half will rest on the spherical washer. So you have to remove this one. You have to remove this one. Don't forget to remove this one. Otherwise, this will restrict the movement of the turbine casing. Turbine casing. So once the A is over, all the tightening is over, all the guide build carrier centering is over, you put this top casing on over the bottom casing, then you see these are the parting plane bolt. This is the exhaust hood bolt, this is the parting plane bolt of the turbine casing. This one is called the high pressure bolt, this is medium pressure, this is exhaust hood bolt. Here we have to do the top half and bottom half 90 to 100% blue matching, and here particularly it is plain, but in big turbine you will see there is some grooves are there here, inner and outer angular grooves are there, 1 to 3 millimeter grooves are there, so that the contact will be this inside and outside, and in center there will be no contact. So center tightening will be very tightening force on the parting plane will be more, because inside there is a recess. Now this particular bolt are called the pneumonic bolt. Pneumonic means it is 50% nickel, made of 50% nickel and 20% chromium, and some titaniums and aluminum additives are there. This can withstand the high temperature, and but only by torque range or hammering you cannot tight it. So we have to use a special type of heating device. That with this heating device we have to heat the part of a pneumonic bolt, and it will expand, and you have to measure the expansion with the micrometer, and then tight the lug nut, and then cool it. Once you cool it, the expansion it will sink, and you will get the required torque. But you have to achieve after expansion, you have to achieve the value QC people has given. QC people have given, and once and when you are removing the parting plane bolt, you have to measure its length in cold condition, and that length is also mentioned. If you find the length is more, that means your parting plane bolt has developed creep, and you have to remove that particular bolt. And not only that, you have to do the ultrasonic test also for each and every bolt, and if any crack observed, that bolts need to be replaced. It is done, the testing will be done by DP as well as through ultrasonic, and the length, cold length and hot length. Hot length is required for getting the required torque, and cold length is required whether permanent deformation has taken place or not. And how which bolt you are going to tight first? Which bolt? If you see, before when you are opening, you have to open the exhaust hood bolt first, and then the pneumonic bolts. If you do not remove this exhaust hood bolt and remove all this parting plane pneumonic bolt by heating, then you cannot remove this one with hammering and others. You have to cut the parting the exhaust hood bolt. So because once this is loosen, it will be too tight. You cannot remove it. So before removing this one, you have to remove this one first, and then to start removing this one. And tightening also, you have to first tightening this one, then you have to tight this one. Then only your effective tightening will be there, and there should not be any leakages. And not only that, there should not be any scratches. 90 to 100% blue matching is there, and you have to use the anti-seize compound, so that when you are tightening both these top half and bottom half and high temperature, it should not weld each other or seize each other. So the anti-seize compound like Virco-seed lead plates you have to use, so that the contact will remain free. When you are removing try to lift the top half, it will come out easily. Now I will going to tell you the difference between the two type of bearing housing. One is called the dash 3 type bearing housing, another is called the dash 2 type bearing housing. Dash 3 type bearing housing, if you see, this is called the dash 3 type bearing housing. These bearing housing are very less in less weight compared to dash 2 type bearing pedestal, and it is mounted to the top half of the turbine casing with the help of a tie rod. And here centering is very easy because it is resting on the spherical washer, and movement of the it is very less weight, and movement of this vertical movement as well as the horizontal movement with the help of the threaded cup, very easily horizontally and vertical movement and angular movement with this is very easy. Easily you can do. Easily you can do. And as it is very light in weight, so when turbine is running, due to and contact area is less, you see the contact area is less, their contact area is less, so there is chances that there is a group will form under the bearing housing, because where it is resting on the spherical washer. So after 4-5 years, if you found some group is there, you have to take out the bottom half of the bearing housing and then machine it and remove this group, because if group is there, the movement of the bearing housing will not be there and high vibration will arrive. High vibration will arrive. Now that is the disadvantage of this type of dash 3 type of bearing housing, because it is very light, very light, and vibration due to light, and after prolonged running in 3 to 4 years, the chances are there to develop a group. But otherwise, it is very easy to do the centering. Similarly, dash 3 type bearing housing, dash 3, this is the dash 3 type bearing housing. You see the dash 3 type bearing housing is resting on the, instead of spherical washer, it is resting on the lubroid plate, particularly carbon impregnated lubroid plate. So here area is more. It is the front side, this is the rear side of the bearing housing. So area of contact is very big, so that though there should not be any chance of making any group. So after 10 to 15 years also, you need not take out the bearing housing. Here bearing housing are very heavy, that's why the vibration is also very less. And not only that, here the bottom half of the bearing casing casing is mounted tight with the bottom half of the turbine casing with the help of pin and spacer, so that when turbine will expand, the bearing housing will expand against this key. You see there is a key, axially it will move against guiding this key as well, and on the lubroid plate. So I think, friend, I have told you everything about centering, why it is required, uh, and how we are going to doing the centering, what is the importance of centering, dash 2 type and dash 3 type bearing pedestal differences. Now most of the turbine are dash 3 type turbine, dash 2 type turbine, because vibration is less, and how procedure to do the assembly of turbine casing. I think your all answer. If you go through these slides, you will get all answer. If you still have any doubt, you can contact me or mail me, or you can arrange a video conference by mutual discussion, so that your all doubts will be clear. Thank you very much.